All right, so it has to be on that side of 0. Next is integers. Anybody already know what integers are?
It's positive numbers.
Positive, negative, what? Whole numbers, that's right. So again, integers still don't have fractions or decimals, but they can have negatives. So we can put -4, -3, -2, -1. 0 is still included. 1, 2, 3, and 4. Okay, up next is this word rational. These are a little harder to remember what they are, so let's just talk about what the word rational means. Yeah, what does the word rational mean? If I told you to act rationally, if you told me to act like a rational teacher, what should I be doing? What does a normal teacher do? Does he stand in front of the class? Does he point at the board? So that's what a rational teacher would do. I would be predictable. You'd walk in and I'd be here ready to go. I'd have my notes ready. Okay? And you'd know exactly what was coming next. Right? You know that I'm going to go from this slide to this slide. From this slide to this slide. Okay? So a rational number is predictable. That's the word I want you to write down for that. Okay? Predictable. Okay, what I mean by predictable is you know what's going to come next. So it does include everything above. Because if I write down the number 1, we know that's 1. There's no changing that. That's just 1. If I write down the number 1.3333 repeating, what's going to come after this last 3? If I kept writing? Another 3. What else? Another 3. Another 3. Right? So that's predictable. We know what's coming next. So repeating ones. Repeating decimals. Okay? If I just had 4.7, but I didn't write that repeating bar above it, what comes after that 7? 0. What about after that? A 0, and a 0, and a 0. So that's predictable. Okay? So if you can predict what's going to come next, it's going to be a rational number. Rational numbers also look like fractions sometimes. But if you change that fraction to a decimal, it acts predictably. Okay? So if we are talking about rational numbers, those are the 2 definitions for it. Okay? What about irrational? So let's go back to my example. If I was acting irrationally, what would I do?
You just act unexpectedly.
Yes, right. Act unexpectedly. There is no one in this room that could predict that I would act this irrationally, right? Okay, so, is that predictable? Could somebody have told me at the beginning of class that I would have done this? Yes. Yes. Okay, so irrational. Irrational means it is unpredictable. Okay, so write down unpredictable. So unpredictable, not predictable, not repeating. You write that down too, non-repeating. Okay? Unpredictable. Unpredictable. Not repeating. Okay, what is the most famous, unpredictable, not repeating, irrational number? Anybody know? Just say it. Yeah, pi. Not repeating. Okay, pi is the most famous, but is not the only one. Okay, so you can write down pi. I believe, like, square root of 2, I think, is one. Okay? So if you type those into your calculator, you'll see that it's like 3.14159, and it just never repeats. You never would know what was coming next unless you actually calculated it. Okay? All right, so that's irrational. So you can see how this is not math right now. That's why I said this kind of stuff is hard to remember. And then last, real numbers. What is a real number? Does anyone know what I would describe? Yes?
Every number.
Every number that you know of right now is a real number. That is correct. So I'm just going to write everything. Okay, later in math, you will learn about imaginary numbers. Sounds like it makes it a lot harder. It does not make it a lot harder, but it does make it harder. If you've ever seen a math problem with that I need to turn those off now that summer is over. Stop it. Stop it. Yeah, if you've ever... Stop it! If you've ever seen this, that is the imaginary number. And we'll kind of mention it a little bit later, but we actually won't work with that this year. The I is the square root of a -1, which is impossible to do, but it still works mathematically, so we use it later in math, not in my class. So right now, what pertains to you is real numbers are everything. All right, so I want you can try on your own, or you can try with the person next to you to place these pieces. Okay? I want you to start here and try to place them in the smallest circle you can. So yes, you can take every one of these and write them right here, because they're all real numbers. I want you to try and place them in the smallest. Number 1 is real, but it's also rational, but it's also integers, but it's also whole, and it's also natural. So put it in the smallest one. Okay, go ahead and try to place those for me. All right, so let's take a look. I will not be writing these in. I'm just going to point. Okay, this is a Venn diagram. I know the Venn diagrams you normally see are just like two circles that barely intertwine. This circle is fully connected with the ones outside of it, but it still is called a Venn diagram. Okay, this is something that is nice to just have in your head real quick. If you want to, we can start here and you can make up a sentence with each letter. Somebody has done that before. But if you write it on the back of your test, you will for sure get the questions right over this. Okay? All right, so just running through real quick. I'm going to skip a couple because a lot of them are very similar. What is the smallest circle that one can go into? Natural. Okay, what about 0? Whole, because it is not a natural number, but it is a whole, and everything above it. So it is also a rational number. Let's jump to a fraction. Where do fractions fall? Rational. Okay, if we turn that to a decimal, that would be 0.5000000. So we know what's coming next. Okay, what about this negative fraction? It's got a negative before it, though. It's still rational because it's still a fraction, and rationals are allowed to be negative. Okay, these are negative, but they have to be whole numbers. These can be negative. These can be negative. Okay, let's jump over this mixed number. I don't like mixed numbers, so don't answer in mixed numbers. And I like improper fractions. They're easier to work with the stuff we do. Okay, but it still would be rational though. Okay, it still would be rational because it turns into an improper fraction, which is a fraction. Okay, what about this negative 25? Where do whole numbers start? At a whole, right? It's at 0. So 0, 1, 2, 3, 4. So negatives have to be here. Okay, I think that's where people mix up a lot. So just keep that in mind. What about this square root of 36?
Natural.
What is the square root of 36? 6. So yeah, it's natural. They make it look harder, but if you solve that first, then it's a lot easier. Okay, square root of 3. Anybody type that into a calculator or anything?
Irrational.
Irrational? Irrational, yes, because it just keeps going on forever. Okay, let's continue on. These ... this ellipsis is what it's called. Just means it keeps going as well, and I don't see anything that started repeating here. So that goes over here in irrational. What about this negative 1.8?
Rational numbers.
rational. Good. Remember that negative is allowed. Everything above integers allows negatives. But if it's a negative whole number, it goes in integers. Okay, and I think those other two are combined in the other stuff. This is irrational because it doesn't repeat, and this is a rational number, a rational one because it is a fraction. Okay, so I really think those are some of the more missed problems on the exam because it's just something that, it's words that you talk about the first day, and I kind of mention them as we go, but it's not something that you just look at definitions over and over again. Okay? So make sure to look those over as we go. All right, symbols to remind you about. You know these symbols. Less than points to the left. Okay? Left than. So if I say, is 3 less than 5, if you think about a number line, I know that's an easy problem, but if you think about a number line, which one's left than? 3 would be left of 5. Okay? Greater than, and then equal to. So let's answer these pretty easy problems. Which one should we put in between these two? Greater than, less than, or equal to? Less than. Okay, I remember when I was your age, the words combined with the symbols confused me because I just was like, okay, I don't know which symbol to put. I just know which way the symbol needs to point. Okay? So it's okay if you don't know what word you put with the symbol. Just make sure the alligator mouth eats the bigger number. Okay? Right? Okay? So the 3's bigger. So it needs to be eating the 3. The 7 is bigger. So it needs to be eating the 7. 72 or 27?
72.
Okay, -1 or 0?
0.
Good, because the -1 is less than, or left than, so it is less than.
Equal to.
Okay, good. We want to solve, just like we solved the square root of 36, we want to solve it before actually thinking about it. So 14 divided by 2 is 7. I should have chosen a different number because that looks like a greater than sign. It's a 7. And then you can answer the question. The question is equals. And then which one is left? Which one's left on the number line? Which one's less?
Oh, 6. Oh.
Yeah, I changed my question, right? I've been saying which one's greater. Okay, -6 is left. So that's the weird thing. That is a greater than symbol. So it's saying -5 is greater than -6. But keep in mind that if you threw it on a number line real quick, just which one's left. That makes it easy. Okay, up next, absolute value. Anybody even know what absolute value means? Yes.
The positive.
Yes, it is just the positive. Okay? Let me tell you the exact definition or exact reason behind absolute value. Absolute value is the distance from 0. Okay? The distance from 0. That means that it has to always be positive. You cannot have a negative distance. You can go down 4 feet, but you don't go -4 feet. If I'm 3 feet from this wall, I'm 3 feet from this wall, and the closest I can get to it is 0 feet from this wall. Okay? Even if I go on the other side, I'm 3 feet from the other side. Okay? So same thing here. 0 is our wall. So put a 0 in the middle. And it says the distance between A, that's our variable, and 0 on the number line. So if we had a negative A over here, it does not matter where exactly you're going to put it. Just write it on there somewhere. And we have a positive A over here. If we found the absolute value of that, the distance from 0 is still A on both sides. So that's the exact reasoning by absolute value. But as Ashka said, it's just when you make it positive. Okay? If there's a negative there, take it off. That's all it means. Okay? All right, so what's the absolute value of 4? What about the next one? What about the next one?
0.
Okay, keep going. Easy. Okay, this is, again, we're figuring out what's greater than or less than. So solve the problem and then answer that question. So first, the absolute value of 0 is,
0.
now answer, less than, right? Or the 2. The 2 is greater than. That's how I was asking. Okay, what's the absolute value of negative 5?
5.
And that's equals. Okay, now we have to solve both sides.
5 and 6.
And greater than. Well, I'm messing it up. Y'all are right. Okay? Yes, it is less than, because you start on the left side. Okay, you read it. Okay, so very simple section. The only part that might be a little bit tougher is the meaning of these words. So, so that first homework section, we're going to take that 3 to 4 minute break if you would like. If you want to log into your homework and just get a couple problems done, you can always do that as well. Okay? Slight break, and then we're going to work with something a little harder, something we don't like too much. Ratio. So something out of something, but I'm just going to write the word ratio next to it. Okay, on that fraction, there's a top, right? 3, let's say, 4 on the bottom. Okay, there are names for the top and the bottom of that. The denominator. I always remembered this as a kid. D. And I made that D is down, which reminded me that the 4, the bottom of the fraction, is the denominator. Okay, the numerator is the top, so 3. Or you can put top next to it. Okay, what is a factor? Anybody know what the factors of something are? Okay, let's put actual numbers to it. What are the factors of 10? Anybody know what that is? 5? Uh-huh. There's 2 more.
10 and 1.
10 and 1. Okay, so factors are just things that multiply to get something. That's one of the ones that I'm not going to write down. Factors are numbers that multiply to get something else. And that something else is the product. Okay, the product is the answer to a multiplication problem. So answer to multiplication problem. Okay, up next are prime numbers. What's a prime number? Anyone, just say it.
13.
13.
3. 7.
7. Any more? There's a lot, there's infinite, right?
25.
Right, so what made those prime numbers, though? What was the reasoning behind those being prime numbers? Anyone can say it right now.
Nothing
Can
will
only be divided by one times.
Good. Okay, so that's the textbook definition. That's good. They can only be divided by one in themselves. But you can also say nothing can multiply except for one in themselves. Okay? So that's what a prime number is. You can only find a couple factors of it. 1 and itself. Okay, so again, going back and using this word, even though I'm not going to make you write down the definition of that word. There are only 2 factors of prime numbers, 1 and itself. So what do you think composite numbers are? Yes?
Every other number that's not a prime number.
Right, it's just everything left over. I rarely ever use the word composite because those are just numbers that aren't prime. That's what we call them. So next to composite, if you would like to write something down, not prime. Not prime, or numbers that are not prime. Not prime. Okay, this last one, let's go ahead and put a star next to it. There is a question on your test, on your exam, on your final exam at the end of the year, on your quiz next class. It says, tell me the reciprocal of a number. So like, tell me the reciprocal of 1/3. Tell me the reciprocal of 5. They'll ask that stuff, okay? So what is a reciprocal? Anyone? Yes?
Like a fraction but like flipped.
Okay, a fraction flipped over. Good. So if we had 1/4, if we take that fraction and flip it over, that would be 4/1. But we don't write 4/1. We just write 4. Okay? So yes, we're going to take this thing and flip it over, and that's how we get this. But 4 over 1 simplified is just a 4. Okay, that's a reciprocal. So again, put a star next to that one. That's the main one that will actually be on a test and say, what is this word mean? Like, what does it mean? Okay? And it's also one that you will get confused with another word we'll talk about later. So I'll make sure to point that out. All right, factoring. I know a lot of these you can factor in your head. I'm going to use a factor tree like you have before. But when I do factor trees, I always stick with a prime number on one side and the other side I branch down. Okay, so 40, you could split it into, 4 and 10 and then split up both sides. But I try to pick a prime number so that only one side needs to be split. Okay, so like 40 can be split into 2 and 20. So then that 2 is already prime. We can circle it and not think about it anymore. If we split it into 4 and 10, we'd have to split the 4 into 2 and 2, and then split the 10. So now we can deal with the 20. The 20 splits into 2 and 10. Again, I'm going to circle that 2. And then split up the 10, 2, and 5. And you only circle them when they turn into prime numbers. Okay, if it wasn't a prime number, we keep going. All right, so that shows us the factors. If it would like you to write the factors down on the homework, which I believe it does, I would prefer, I don't think the website cares, I would prefer that you write them in numerical order. Okay, some of you might be thinking, can I write 2 to the 3rd? Anybody thinking that? Anybody thinking exponents yet? That's next time. Okay, so just write 2, 2, 2, 5. Okay, and then you can always check yourself. Make sure that you didn't mess this up. Actually, just take your calculator that you have in your hand most of the time, even if you're at home on your phone. That is a calculator. Just 2 times 2 times 2 times 5 is 40. We know we got that one right, as long as those are all primes. Okay, 63. What are the two numbers that come to mind with 63?
21 and 3.
21 and 3. That's a good one. Okay, 21 and 3. Because 3 is a low prime, and then 21 can come next. There's no right answer for that step, because you're going to, in the end, get the same primes. So some of you might have thought, anybody get something different? Anyone? Nothing? What about 9 and 7? Right? Because the 7's prime, and then the 9 splits easily into 3 and 3. But we'll get to that anyway, because this 21 turns into a 3 and a 7. So then your answer is 3 times 3. Oh, they want commas. 3, 3, and 7. So there's your answer for that. There's your answer for that. Okay, go ahead and do those last two. Once you get done with those, just look at somebody's iPad next to you, see if you got the same primes at the end. It's okay if you got there a different way. Some people get there a different way on 75. And you are allowed to split it up into stuff that's not prime. I'm just telling you, I split it up into primes. So, like on 36, it looks pretty obvious to split it into 6 and 6 and deal with both sides. So you can do that. I'm not telling you not to. So up there I've got the answer to the 36. I did go ahead, I don't know why I circled the 6s, but I did go ahead and do 6 and 6 just because that is a super obvious two factors for 36. What about 75? Anybody split it up on the first step into something? Okay, what do we think?
3 and 25.
3 and 25. That's the first one I thought of, but a lot of people tend to think of a different one.
15 and 5?
That's the one that a lot of people think of. I would have never thought of that, but a lot of people that sticks in their head for some reason, because I guess you see that it ends in a 5, and you know that 5 is prime, right? So you just went with that. Okay, so we could get 15 and 5. 5 is a prime, 15 is not. Split that into 3 and 5. You still get to the same answers. 3, 5, and 5. Okay, so again, I know that you can probably, on a couple of those, just get straight to the factors, just because you've worked with that so much. I am not requiring you to write down factor trees. I'm requiring you to factor. Okay? So if you have a different way, you have an easier way. Some people know like a birthday cake method or something like that. I think they teach that in TCA. But a couple people know that and use that. I'm not going to grade how your work gets there as long as your work gets there. Okay? All right. The reason we talk about that is for fractions. That helps so much on fractions. Okay, so if A over B is a fraction and C is a non-zero real number, so if it's not 0, then this works. Okay? Can anyone tell me, because of this, why does C have to be non-zero? Anybody know? Mason?
0 times anything is 0.
True. That is a good thing. Any other reason? Yes.
If it was A plus B times C, and if C was 0, then it would equal C.
Which would be 0. Yes.
Yes.
Okay. Any other reason? Anything about this and a 0 being there not allowed? If I put a 0 on the bottom of a fraction, is that allowed? No, it's not allowed. So that's another reason why. Okay. Here's my reasoning behind that. Okay, to have a 0 on the top. No, you can't have a 0 on the bottom. Okay? A lot of people can't remember which one's undefined and allowed. It is okay to have the 0 on the top. That's just 0. But no, you can't have a 0 on the bottom. Okay? All right. So that is the why, though, is what we talked about a little bit. If this was 0, then the whole thing would be 0. But if it's anything other than 0, like if C was a 3, why would this end up being the same thing over here? Yeah.
Because it would divide out into 1.
Good, because anything over itself is 1. Okay, so we use that when we multiply and, when we add and subtract fractions. So first let's factor fractions, we'll multiply fractions, and then adding is when we use it the most. Okay, factoring fractions, this is where I'm gonna stray a little bit away from the factor trees, and I'm just gonna start splitting stuff up into factors. Okay? So we're still gonna do the same steps, it just won't look like a tree. So when stuff turns into fractions, we just treat it as two separate problems. Fractions look horrible, but if I just look at the top, then that's just what we just did. You're just factoring 42. So just look at the top and split up 42. So 7 and 6, the 7's prime. So let's keep going with the 7, and then the 6 splits up into a 2 and a 3. Okay, on the bottom, that 49 can turn into a 7 and a 7. Neither of those can be split up again, so I'm just going to write them again. So this is another thing where I think you could probably simplify this in your head. But we're giving you the reasoning behind it for later reasons. Okay? So if you break everything down to primes, you can see that those 7s are going to turn into a 1, just like C over C. So that's why 42 over 49 simplifies to 2 times 3 is 6 over 7. So it's the real reasoning behind it. That means on your homework, you might hit a number that's super big over a number that's super big. And you don't know how to simplify those just real quick in your head. Just break them down to primes, cross out the stuff that matches. Okay, there is, I think, a problem on the homework that is pretty big numbers. Okay, what about 11? Can you break that down any? No. So we're going to go ahead and just write 11. What about 27? 3 and 9. The 3 is prime. So 11 over 3 times 3 times 3. Okay, now we've got all primes. Is there anything we can cross out? No, so you can see that we couldn't do anything, so our answer is exactly what it originally was. Okay, break down those last two. "88 is another one where people have two different directions they go. They either think 2 or they think 11. Okay, on the first one, did anyone get 22 over 5? Awesome. Okay. Again, you will get to that answer if you didn't use these two factors. If you did 2 and 44, that'll be fine. Okay. If you split it up into 4 and 22, then you'd be fine too. You just have to split both of those, right? Okay, last one. 7 over 5 times 5, nothing can cross out. So again, we just multiply it back together, which was our original question, as 7 over 25. Can I move on? Can we jump over that now? Anybody copying stuff down? Okay, multiplying. Multiplying is extremely easy. You just multiply. You just multiply top times top and then bottom times bottom. This times this. This times this. If you did that, you'd have to do 15 times 13. That's a big thing to deal with. So we know of a way to make that easier. What do?
You take the 5 on the other side. I know it's cross.
I don't know what, cross simplification maybe? I don't know what words they use.
5 into a 1 because 5 goes into 5 once, and then 5 goes into 15 3 times.
Right, so if this was a fraction, 5 over 15, you would simplify that fraction of 5 over 15 to 1 over 3. That's what you're doing. How I'm going to always do it is I'm going to take, I guess I'm already in green, I'm just going to cross like this. Okay, so we just simplify it as much as we can, and then we multiply straight across. So 2 times 1 is 2. 3 times 13 is 39. And there's no way to simplify that, but if there was, we need to keep going. So if you could simplify 2 over 39, we would. Okay, what about on the next one? Is there something we can simplify or cross out?
Yeah, 3 and 9.
The 3 and the 9. So 3 here, and 9 turns into a 3, because 3 over 9 would have simplified to 1/3. Okay? Then we multiply across is 7, and 8 times 3 is 24. Okay, this one says divide. Anybody remember the difference in division?
You switch 5 over 16 to 16 over 5.
Okay, and that's where that word reciprocal comes in, right? Okay, you multiply by the reciprocal of the second fraction. You do not flip the first. Only flip the second one. So we're going to flip it, and then we're going to multiply it just like before. So 4 over 5 multiplied by 16 over 5. Okay. I think I wrote that down wrong because it looks like that 4 really wants to simplify with that 16. Okay, so what's 4 times 16?
64.
64, and 5 times 5, and there's nothing we can do with that. Okay, last one. It still says division, so we have to flip something. What do we have to flip?
1 over 14. 1 over 14.
Good, so we flipped to 14. It's not a fraction, so let's go ahead and throw a 1 under there so it looks like a fraction. And then flip it. So 7 over 10 multiplied by 1 over 14. So 7 over 140. Anybody know what that simplifies to?
1 over 20.
1 over 20. Good. Okay, last thing. Last concept, at least. Okay, adding. Adding is a little bit harder. I think they might have referred to it as like apples and oranges or something like that in earlier grades for you. Adding, you have to have a denominator that matches. So the bottom has to match. Multiplying and dividing, it does not. So if the bottom matches, that's extremely easy. You just add the tops together and use that same denominator, because that denominator is just a label. It's what's describing those numbers. Okay, so I can add a 2 and a 4 because that 7's already there. So 2 and 4 is a 6. Same thing for subtraction. 9 minus 2 is a 7, and that bottom was already there, a 7, but that is not a simplified answer, so our answer is 1. Okay, so it's very, very, very easy if there's a same denominator. So sometimes we have to make it into a same denominator. Apparently, I write this differently than your old teachers, just so you know. And this is how I'm going to write it the whole year. Again, if your work looks different than mine, as long as it gets you to the right answer, that's fine. But this is how I'm going to do it, even with harder stuff. And the reason I do it this way is because it works better with the harder stuff I deal with. All right, so we need something that both of those denominators can turn into. What do we think? Just somebody say it.
20.
20, okay? It's easy to figure out. Easy to figure out. Later, it's going to be a little harder to figure out. If we put x's down there, it's going to be a little harder. So 20. So we got to figure out how to turn those into 20. So looking at that first problem, what do I need to multiply 5 by? 4. Okay? And we need to multiply it by c over c. Remember, we can only multiply by a 1. So c over c, so if we multiply the bottom by a 4, we have to multiply the top by a 4. Okay? So let's go ahead and do that and write that over here. 2 times 4 is 6. 5 times 4 is 20. Okay, and then we're going to add that to something. What are we going to multiply the bottom of the next fraction by? What does this need to be multiplied by? 5. Okay, so 5. And we have to multiply the top by that same thing. So that is 5 over 20. And now we can add them together easily. 11 over 20. What did I do? I was adding. Yep, there it is. There's the first mistake by the teacher. There will be a lot more of those. 8. Okay, so that is now 13. Yeah, that's the answer I remember. 13 over 20. I knew it looked weird. Good catch. Okay, so yes, 8. I accidentally added those, which means that's probably a common thing, so be careful of that. Just because you're working so fast, you know that you're going to add later. That's probably why I did that in my head. Okay, sometimes if I'm working quickly and I'm not rewriting the whole problem with these next to them, I might do something a little different. So I'm going to show you that here. If instead of spreading it out, what's the least common denominator of these three? What can I turn every bottom of a fraction into? 22, right? I can multiply that by 11, multiply that by 2. So I'm going to do that same thing, but I know that I'm going to multiply the bottom by that. So instead, I might do something like this. What is this fraction going to be multiplied by?
11.
11. So I might just do that real quick and then multiply top and bottom by 11. So 11 over 22. Okay, what about this middle part? Leave it, because it's already a 22. So plus 17 over 22. And then this last one, what is this going to be multiplied by? 2, because that 11 needs to multiply by 2 to get 22. So minus 4 over 22. So I might write it like this occasionally, but that's for these smaller problems. On the big ones, I will always write it like the bottom of this slide. Okay, so when we add and subtract those, what do we get? 24 over 22, and then we can simplify that. 12 over 11. Okay, last thing, I added this on late because I saw it on the homework and people had questions about it. It says write the fraction as an equivalent fraction with the denominator of 36. So basically it just wants to turn the denominator, the bottom, into a 36. How did I turn a 9 into a 36? What did I do?
Multiply by 4.
So just multiply the top by 4 as well. So that 9 had to be multiplied by 4. So the top also has to be multiplied by 4 so that we get that C over C, that 1. And so 5 times 4 is 20. Should I simplify that? Yes or no?
Yes, you can.
Yeah, but should I? Okay, so you can, but if you simplified it, it would turn back into the question. It would like the denominator to stay at 36. So I know that that looks like it should be simplified. But if it asks us to change it, we need to, because if you look at these can also be simplified. We're changing it to stuff that can be simplified so that we can use it. Okay? All right, any questions, any slide you need me to go back to at all? We're good? Awesome. We'll see. You got 20 minutes. You can get done all your homework. Okay, I know today was a lot of review, so if I'm ever going too slow, let me know, but I know that some people might need a little slower, so some of y'all might like to just work ahead on the notes sometimes.